We are going. Hello everybody, let me know if you can see and hear me. Please, please. I see I'm through to YouTube. DCD is typing. I thought you were out, DCD. Hi, DCD. See and hear, great. Do we wait for somebody else? Hello, Beata. All right, let's get started. I got started a minute late. So, hello everyone. My name is Scott. I go by Tannu Online, and I work for Adafruit on CircuitPython. If you don't know what those are, Adafruit is an open source. Yeah, I found sounds. Here, I'll turn it down. I have the AC on because I'll melt otherwise if I don't. I turned it down a little bit. Hopefully it's a little bit better. There's like 2 fan levels. Yeah, so Adafruit is an open source hardware and software company based out in New York City. They sell all sorts of different little boards called, development boards, things that you use in projects that you can use to make whatever you want. This is an ESP32S3 with a screen on the front, and this is a feather form factor, so there's other feather wings that you can stick on top of that. And what's under here, under this metal part, is a little chip that's a full computer. It has RAM, CPU, and flash that acts like a hard drive, all built in. So you plug in, and when you plug in, if you've loaded CircuitPython, it shows up as a drive called CircuitPy, and then you edit the code.py, which is Python code, on it, and it will execute all on board that one little tiny computer. So you can do all sorts of different things. You can make things blink. You can have it act as a keyboard. You can have it as a mouse. You can change the display. You can talk to the web. All sorts of stuff. So CircuitPython is open source as well, and our goal is to make it really, really easy to program microcontrollers to do what you want. So this is a deep dive where I talk about what I've been working on in CircuitPython land, and I've been in like an LLM land this year, but now I've also been in hardware land. So I'm this week I kind of gave myself a little bit of constraint. I wanted to work on the GameBoy cartridge, trying to get it over the finish line so that we can actually sell it. And so I talked about that all last week about how I was getting the PIO to DMA back to PIO. I did manage to get that all working this week. And I do want to do some testing with that, but I also had a meeting with Lady Ada. Her name is Lamore. She is the founder of Adafruit and owner of Adafruit. She does hardware stuff usually, and so we reviewed the circuit board for the Game Boy. I can show you. So here's a DMG. There's no batteries in here, so I can't turn this one on. But there's a custom cart that goes in the back of it. And this chip here is the RP2350, and this runs CircuitPython and other code as well, and it can act like a Game Boy cartridge. So I'm trying to think of a good name for this cart. I have like Game Boy in the name, and I don't want Game Boy in the name, but it's basically like giving it a new brain, or like I was also thinking about it in terms of like puppeteer or something, right? Because it's like it's controlling what the Game Boy should be doing, kind of from that computer instead. So I got a lot of feedback from Lamore about how we could improve this cart so that we could get it in the shop. I do want to do some testing on it today, so I have this cable here. I want to do some testing on the MIDI, which I actually haven't tested yet, but should actually be really straightforward. So I want to test that. I've got a Game Boy Pocket here that I've been using for testing. I tested the UART, and I want to test the stemma QT as well, but I might actually have to take my mic off or just skip that. So yeah, I wanted to show, maybe I'll give a little preview of what I've been doing on the hardware side, and then we'll actually fire it up and see what we have working. I'm able to actually like get data written from the cart and capture it, and then also write commands out to the cart, which is pretty awesome. So let's go to the desktop. So this is some code for the Adafruit Game Boy library. And again, I need to think of a new name for this. I was trying to, I have this game called Celeste that's based on Pico 8 that I've ported to Python, and I was trying to get it working, but it's complicated. So I need to go kind of back to basics and make sure that we can get everything everything kind of where I want it, or like start with first principles and simple tests, and then build up from that. But I thought what I'd show, I thought I'd briefly talk about the changes to the Game Boy cart first. One small thing is we added a diode here for being able to read boot separately from the flash and PSRAM. So Lady Ada thought we should have PSRAM on there, and she had ways of squeezing it in. And so we'll see that in just a moment. I moved things around. We put resistor packs on all the 5-volt inputs just to, in case we get 5 volts coming in here without everything powered up. Some more decoupling capacitors around the voltage regulator. And then a NeoPixel. NeoPixel was her suggestion as well. And then I think Cooper asked about this, but I think I can fit an SD card now, a micro SD card. I think I can manage to pull it off on there, and I'll show you. I haven't quite done it yet, but I think I can pull it off. I had added debug uart, but I also added debug SWD. Lady Ada's point was that LLMs are actually getting decent at doing debugging using GDB, so you probably do want an SWD connection. So the Raspberry Pi folks have kind of like set up this 3-pin kind of standard for SWD, and so I just threw one of those on there as well. So that's where I'm at. I haven't gotten it to the point where I can order it yet, but I will show you where I am at with the cart. So here's the new version of the cart that I've been working on. So the RP2350 was over here, and part of the reason for that was the older versions of the cart had big logic level shifters all down here. So there wasn't, like, it couldn't scooch as far down as it does now. So Lady Ada had the idea of scooching it down here, which frees up a lot more space up here. And this is the part I haven't, I'm still working on. So I think what I can do is, well, so here's the flash, and then PSRAM is here. I have to run this 5 volts power up over here into the regulator is now here. It was over here, and now I've put it up here. Her feedback was that it should be closer to the RP2350. And I think this is a decent spot. Obviously, I haven't actually routed it yet. I kind of started from the bottom of the cart, and I'm working my way up. So I've done all the resistor packs. I scooched the data line shifter down. One thing I would maybe like to try to test today that would be good is this audio filter that Toddbot suggested to me. I actually haven't tested it yet, but now that, and the reason I hadn't tested it is that you actually have to turn on the mixer to enable like a 5th audio channel. That's the input audio. And so in theory, we could test this today. I think I'm a little scared to know whether it works or not. But I do need to test it because like that's part of what we're doing. You can see here's the new connector for SWD. Here's the debug UART. So I think what I can do is I've already moved it. If I scooch this over, I think I can fit a micro SD card right here where this reset button is still. It looks like it deleted my box, but I had a test rectangle here that I was putting for the footprint of the connector, and the connector style I was looking at that Lady Ada had suggested is this one. So here's JLC parts, and this type of micro SD card, which is like super narrow, just wide enough, and kind of like it hangs out a lot. And so that's why I think I can basically like hang the micro SD card like up above the cartridge, and it'll be okay. People might want to print cases and stuff for it, but I think that'll work. So yeah, I'm working on that. I've got to make a footprint, an actual footprint for it. So that's what I was doing before my stream. But I've been doing so much hardware stuff. I think I want to do that. I had a Pico style UART connector as well as SWD. Yeah, so right now they're vertical ones. So this is the UART one and this is the SWD one. This position is subject to change. But it is like similar to how it is on the current cart. Maybe you can see it there. See like this connector here. So when it's in, you'll see I have this blue line and the thing that says like don't put stuff below that. That's based on where the slash in the version number is, so that like that's where like buttons and plugs and stuff have to be above that. So I'm thinking about, I was going to put a button under here, but that might be, I could reach in there. There's space under the MIDI there. Yeah, so I'm figuring out how to scooch the top. I put the stemma QT a little bit over by moving. I can move this LED further down. It doesn't need to be on the edge. And I got my DNG out to make sure that it had clearance as well. I was actually thinking about putting the micro SD card from the side, but the sides of the Game Boy are high up all the way, so we wouldn't be able to do that. You can't hang off that way. So those are the things I'm thinking about for modifying it, or I'm working on to modify it. But let's actually like show it off. Let's actually do some tests, because I probably should have done it sooner rather than later, but making sure that the MIDI stuff works would be good. So let's start by doing the MIDI test. And we don't actually need to talk to the Game Boy at all to do that. That is just a CircuitPython thing. So if we do the overhead, you'll see, if you see the camera moving a little bit, it's because I'm 3D printing something right now. So it's wiggling my desk a little bit. Sorry about that. Hopefully the focus won't be too unhappy. I don't know how much longer my print's got. It's got a surprising amount of time, I think. I'm printing a pole helicopter thing. I printed one and the kids like it, but I only printed one. And I got purple PLA, so I'm printing it in purple. Okay, so let's just show what it does. So I showed this on show and tell, but why don't we start there? So CircuitPython starts up. It has the Adafruit logo, and then I think it starts again. So when CircuitPython starts up, it's doing a reset, but then when code.py runs again, it does a reset as well. And then if it has the example I was thinking of, so yeah, so this is a entirely LLM generated demo. I said just make one that tests sprites, and it also does keypad. So if you can see, there's a little sprite on top of everything that moves with my keypad. And so this is demonstrating our ability to write patterns to the Game Boy and also to read the gamepad state back. And this is all happening during the VSync or the VBlank interrupt. So it's basically, the Game Boy should be halting every at the end of every frame. It waits for a VBlank interrupt. It jumps to the VBlank interrupt that it loads from CircuitPython. And then CircuitPython has a number of commands that need to be queued up. The stuff that's related, the memory in the Game Boy that's related to the display, you can only modify for 1.1 milliseconds after VBlank. So what the GBIO module is doing is it's storing two command buffers, one that's like priority VBlank stuff, and then stuff that's not critical for VBlank. And then it does the priority stuff, and then the non-priority stuff, and then it exits VBlank. It should halt and then wait for the next VBlank thing. And maybe I should show that. Do you want me to show that? Okay. Again, I should say, I never said what deep dives are. It's what I'm working on, and if you have questions, feel free to ask them. I'm happy to go in the weeds there. So let's see, can I do desktop with overhead? I can. So I'm going to move this KiCad out of the way because I've been doing enough KiCad on the stream, and frankly, I need to do some tests. So what do we have in here? I don't even know. So this is the GameBoy I/O module. You can see we have pin definitions here. These pin definitions will change again because in V9 I've moved things around yet again. I've learned that I swapped where the control signals are. You did not mention the connector. Yeah, it's Pico style UART and Pico style SWD. It's an RP2350, so it makes sense to me to do that. So here is a 64K data buffer. So we're basically acting like a cart. So the way that we have is the stuff that we talked about last week is just loading memory from this like 64K buffer. It can also write to that 64K buffer. So that's how we get data back. So the thing that's interesting, I haven't gotten Game Boy Color working yet, but it shouldn't be too bad. And we talked about the DMA stuff. Let's talk about VBlank, where I settled on VBlank. And I don't know, these are all LLM generated stuff, so I don't actually know if those are true. But so this is the VBlank handler. This gets copied into memory, the 64K of cart memory that the DMA is accessing. So once I got writing back to CircuitPython working, I did this thing where I can write values to mark what phase the interrupt handler is in, the Game Boy's interrupt handler is. So at the start, it writes A1 to this memory address, which is an offset into that 64K. And then after that start, it jumps or it branches to some other code. It calls a function, which is this like queue of instructions for the VBlank. And once that returns, it goes back to here and marks phase 2. So this is like the critical VBlank commands are done. Now it does some random stuff to read the joypad state, which I haven't looked. I like figured this out at some point, but I don't actually know it now. So it does critical VBlank stuff. It then captures the joypad state, and then it writes it back to memory. So you can see there's an offset here of GB RAM gamepad, which would be nice if it was actually matched out, but yeah. So there's a place there that the gamepad state is written to, and that's written back into like the RP2350 memory. We go to stage 3, and now we do the non-VBlank commands. We increment a counter, which is actually not that helpful, and then we mark that we're complete. We finish our interrupt handler, and we do ret_i, which returns out of an interrupt and starts other interrupts again. So that's like kind of the critical piece of connecting CircuitPython to the Game Boy. The idea is that the Game Boy, the GBIO module is pretty straightforward. It is just allowing you can see here there's VBlank commands, which is just a buffer of literally like instructions that run on the Game Boy CPU. And then there's also the non-VBlank version of that. So these are commands that can run at any time. They don't run immediately, this says, and it doesn't block either. But they will be run in the order that they are queued. And then there's this get pressed that is like getting the joypad state. You also have the ability to synchronize to VBlank. So this is like if your game wants to run at like the refresh rate of the Game Boy, you just then wait for VBlank every time. You have the ability to reset the Game Boy. That's why it turned on twice. And you have the ability, or at least will, have the ability to detect if it's a Game Boy Color. How hard would it be not to use raw machine code and instead use assembly code? What are the trade-offs? We could totally write an assembler. We could totally write an assembler for this. I don't think it's very interesting because you're actually, like, generally you don't need to run logic on the Game Boy. All you're doing is using it as a, like, pass-through for writing memory. Right, there's like regions of memory that dictate like playing sounds and setting up sprites and moving sprites. Like, you don't need the logic anymore, so the things that you're doing in those instructions is like pretty straightforward. So what I had done ages ago is that I think it's this Adafruit Game Boy. Maybe not. So this is what this was trying to do, and it's funny to look at this now because it's all handwritten. Like, this is pre-LLM. But this is trying to do display I/O. So we have a tile grid, but it's backed by the functionality of the Game Boy itself. So you start a Game Boy with, you start a tile grid with the Game Boy, and like you can then treat it like a display I/O tile grid. So yeah, it's been kind of interesting to do that. I've got to test this stuff. So there's group. So it's meant to be like a display I/O, and then I don't know what tiles is. It's been ages since I looked at this. And then there's a Game Boy class, and I think the Game Boy class has. This is just buffers. So it only has these commands of like, write this value to that address, and that's all it does for you. So here you can even see, like, here's a routine, and we're writing it to this address range, which is interesting. Yeah, so I've got to look at this, how this works. But so set item is, it allows you to say, like, write this value to this address in Game Boy memory. And then it knows like which ranges need to be vblank commands or regular commands. Yeah, so it's been a long time since I looked at this, but the idea was that you're really just being I think it might have turned off because the batteries are down. Like, the light's on, but it's not super bright. We'll see. We have the light there. I might need to get some fresh AAAs. It seems to burn through them pretty well, even though I should be halting now. Yeah, I mean, so to answer DCD's question, like, you could write an assembler if you wanted to. And now I see that my Discord window is not updating. Or... anyways. There we go. But I'm over it anyway. Just go like this. There we go. Huh. So I think the batteries are dying. Let me just grab some new AAAs and we'll see if it comes back to life. It seems to burn through them pretty quick, but then again, I like leave it on for a while. I've got some freshly recharged freshly recharged AAAs. I will put them in the Game Boy. So yeah, right now the cart is not even plugged in. So the Game Boy is running the RP2350 as well. Oh, you can't see me. Put AAAs in, and let's see how it does. I feel like the light's brighter. Hey! Bing! You probably can't hear the beep. I did actually verify that we're able to play sound. So yeah, this second one is when the code.py. I think it's pretty nice when you're developing for this that like a code.py just resets the Game Boy to start with, because then you know like the state of the Game Boy that you're starting with. So here's that demo again. It works. Okay, so we are halfway through. Let's see if Hams Labs has a question. Heard the beep. Great. Let's hack on it. So let's go. Oh, I gotta plug it in. Plug it into my computer. So yeah, my goal is to get back to the hardware in the loop stuff next week, which is kind of aggressive. So I've plugged in my analog pocket USB, which somebody last week was eagle-eyed enough to do. So I'm just going to rename this code.py to sprite test. And then I think I might actually just see if I can vibe it up. I had really good success with an LLM just generating the test code for me. So in here, let's do a code.py for CircuitPython on the pygb 50. Test that the MIDI in and out work. So use uart to send from out to in. Yeah, so it's been pretty interesting, like what those demos are. I should also try the audio. And in fact, let's switch to this one. Okay, so this is the prompt I had where I had it generate things. Blanks the screen 3 times by toggling LCDC. See, it's not. Yeah. Okay. Let's do a similar one. Write a code.py to run in CircuitPython on the RP2350 pygb board to test the audio output to the cartridge. You'll need to pull it the input audio channel in the Game Boy and use synth.io generate sound into it. That's going to be a harder one for it to do, but we'll see. Okay, so here we go. This one is done. Oh, it wrote it as code.py. We should snag it pretty quick. It's in YOLO ports. Raspberry Pi, code.py. It is 4.9K. Don't do MIDI. Make it much simpler. Just a test message. They love to be complicated. UART loopback test, that's what I'm looking for. All right, 900 bytes, that's more like it. I'm like astounded at how good the models are at generating CircuitPython code. So here, let's do TO. No data. Okay. Check jumper between GPIO 0 and GPIO 1. All right, well, it's not working. Let's take a look at it, the code. This is old code.py, so let's close this, close this. We should be able to do it as a loopback. That's not the code.py I want either. What the heck? Zed, you're failing me. Okay. MIDI in, MIDI out, board dot. Read that much. All right, well that looks like the, that looks like what it should be. MIDI out, MIDI in. No data. Great. Okay, so I do have. What I didn't think about the fact is that I am. Yeah, I think they have the GPIO in and out correct, but this is where I'm like, oh, I have the wrong KiCad file open. Like I have the newer version where I changed one of the pins. So yes. Oh, and then I could scope it as well to see if I'm getting anything. I could also do key canvas. Let's just see if we can see it on here. Darn. Well, I have to respin it anyway, so let's take a look. So, it's too small. So, do I have nets? Footprints, nets. MIDI. No? I don't have nets, huh? think this R7 pin 77 goes here straight to the output. So R1 and R2, and then R1 and R2 come back in. I mean, it seems like it should be quite straightforward, but let's see what pin 77 is. Maybe my pinout's wrong. Which would do it. So I'm pulling up the data sheet. Pinouts. Pin 77 is GPIO 0. And GPIO 1. Maybe how are the MIDI connectors looped together? Like physically, I have a cable that are connecting the two. There is an opto isolator, and so it's possible that the opto isolator is not working. So it should be TX on GPIO 1. Let's just make sure that that is true. I don't want threads. I don't want MIDI out. Print show. Out is GPU 0, GPU 1. I wonder if it's inverted. I wonder if it's inverted. Let's get the CLI out. Let's just see if it's going through the cable, and if it's not going through the cable. Okay, so I've got my Salier, although I need the one with need some clips. Actually, I only need 2 clips. One for ground and one for TX line. And then I gotta find the USB cable for it. This is where it's like, I'm definitely reaching for, like, I want a source of truth. Like, is there something coming out the wire? Is there something on the wire or is there not? So now, if we, I don't know if I can, let's take a look at this circuitry here. It's not quite right, but this is the same. So there's nothing grounded. Oh no, this is going to be the ground from there. So the right one is going to be ground. I can easily clip onto these. I didn't, like this circuitry I got, oh, you know what I'm seeing? No, that's pin 1. That's right. Okay, let's pull up. Is there an enable line on the optocoupler? I don't know. I will have to look. I did not double check that circuitry. Before I did it. I was in a time crunch when I did it, so I have to do a respin anyway. So now's it's good that I am. It's good that I'm testing. That is what I should do, especially because I'm. All things considered, this might be the last revision before we can sell it. The problem is that it's waiting for a rising edge, which we are not getting. Code.py tries to do a uart write every 1 second, so we should have waited long enough. Let's see here. I have the right. This back one should be. No trigger. It should be pretty simple. Yes, I did say last revision before we can sell it. I'm hoping to see it in the Adafruit shop at some point here. Okay, I think this was just me dropping it. I don't think it actually output anything. Let's try again. Oh, I gotta charge my watch. My watch is like, I'm dying. Okay. Let's Control C it. Let's put it back and see if we get the first one out. We should be able to loop it back. That should work. Okay, we're waiting for a trigger. Sent, but no data. And we're still waiting for a trigger. Let's, I think we get a count of how many. Yeah, it thinks it sent it all. Like this should work. Okay, you know what? I could take it out of the Game Boy and still try it. So we do have this. Let's see. We can use the USB connector to get ground. And oh, see, it got something there, but oh, you know what? I should get my thing out. Where's my? Where's the ground on the flash? 4. You are a work of art. Oh, come on. I do kind of hate these clips. Is that how I get them to do what I want? Saying I hate the clips. Huh. Are we still running even though the Game Boy's? It claims we are. Why wouldn't we be getting? I think it's going out that resistor. Oh, my print is done. Happy little chime. Do I have the right one? Am I? You know, I just plugged it in more. I just pushed it in a little bit more. Beep, 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 beep. Beep, 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 beep. So that's the flash. The flash is showing something. And then I don't have a great spot. And this is on the input. I'm kind of stumped. That's correct. DCD asks, what is the code flow? It doesn't involve the Game Boy. Yeah, it shouldn't involve the Game Boy. This is just like, was meant to be a feature so that you can like interface a Game Boy with your MIDI stuff. And if you look on my YouTube channel, you'll see there's this old video I did now where I had like 3 or 4 Game Boys and they were all playing a song together, where like the first one was getting the MIDI in over USB, and then any extra notes it couldn't play, it forwarded on to the next Game Boy, which is pretty fun. I'm a little stumped. Like, okay, let's look at the MIDI circuit. So, MIDI out. Ignore the fact that it's missing here. Imagine it was connected. I know I removed it. MIDI out. GPIO 0 goes here through a resistor value 51. The tip is positive and the shield is ground. So, and then tip here, positive, shield here. So shield is not, okay, so I wasn't comparing against ground. I was comparing against 3 volts. But then, so the signal should go out R1 and R2 and back in R1 and R2. And then the tip is positive, and it should go in here, blink the thing, and then go out. But right now I have it doing, it should be against ground. David says, I don't have a Game Boy Classic except the Lego version, but I have 1 Game Boy Color and 3 Game Boy Advance. Should I try to get a Game Boy Classic or a Game Boy Pocket if I want to enjoy this future new product? No, it should be pretty easy to get the Game Boy Color working. So if you have a working Game Boy Color, like, it's quite similar. And I had it working with the old cart. I had Game Boy Colors working with the old cart, so I think it's totally feasible to get Game Boy Colors running. Game Boy Advances are a whole different thing, but Game Boy Color I would expect to work. Yeah, so I want to get Game Boy Colors working, but I feel like this is supposed to be easy, and it's not, unfortunately. And I don't know what my problem is. Maybe I have a diode placed backwards. That could be it. Let's take a look. So in the schematic, pin 77 is 0. I've snagged 0 for now, but in the old one, it was output, and that's what we were connected to. I guess I could, I wonder what an analog capture would show. So let's do an analog capture. Okay, stop. Let's do an analog capture and just see if we see some blips. No, I need to actually have it grounded. I'm not currently grounded. I think that's the ground on the flash. So let's capture and see what we see. We're just at 0 volts perpetually. Although we see it tweaking a little bit. There's a little bit of wavering, not enough to know. So why would we be... Did the LLM generate the code to initialize the MIDI as a UART function? It did. This whole thing was generated by that. It looks okay to me. Yeah, can you just write a 1 or a 0 to the output pin? Yes, that's a good idea. So let's just do this. And we will do import. Out equals digital in out or dot midi out. Well, dot switch to output value is true, and then oh, we don't have not mounted. Okay. Yeah. Okay, let's logic it. It's still 0 volts. We should be setting it high, and it's saying it's still 0 volts. This resistor is where it is. Okay. So that resistor is high. What? Oh, it stopped. I wish I could snag onto this here. Okay, so there it's low. This side of the resistor is low. This side of the resistor is high. So something is keeping it low. I wonder if it's possible my opto isolator is backwards. Like I have it oriented wrong. I wonder if that would do it. Okay. Let's go to the overhead. Let's take a look at this circuit. Let's zoom in. What did I place backwards? Something is pulling it low. What opto isolator did I use? Enhance. Oh, it's not clear, is it? Oh, it almost had it. Is that what you meant by enhance? Here we go. So pin 1 is in the top right. And which opto isolator did I use? Go here. I realize you can't see my screen. The opto isolator is SM-DIP C78589. C78589. Is that what I said? Yeah. Everlight opto isolator. John says the Croco cart, it works in the DMG color and analog pocket. We're just about out of time, but if folks have ideas for a good name for this, let me know. Let's take a look at this. I wonder if my schematic is wrong. See, like pin 1 should be high and 2 should be low. It emits to the output. Pin 1 should be there unless something is pulling it low. I wonder what if it's low if I unplug it. What's the other side of the resistor? I think it's that resistor. Oops. Took it off. Dee 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 dee. All right, we're just about done. If folks have final comments, now's the time. Oh, see, it's high now. It's high now. But if I plug the cable in, it's gonna be low. now it's low. So it's something on the other circuitry. So on the input side, the tip, there's a diode between there, but that shouldn't be. It shouldn't be completely low if it's going across this correctly. Are there other open source hardware that use the opto isolator in the library model? 1 and 2. If D4 was backwards, it still would be fine. If the pins in and out got reversed. Yeah, I'm not sure. Arpeggio. Arpicart. TMG, OMG. All right, I'll wrap up. I'm going to keep looking at this because it's driving me a little nuts that it just didn't work. And I will fill you in next week about what I find. So thank you all for hanging out with me and discovering that I can't get anything working. My name is Scott. I work for Adafruit on CircuitPython, and occasionally I do hardware anyway. If you want to support Adafruit and myself, you can go to adafruit.com, purchase hardware there. You can find me on the Discord server, which you can join by going to the URL adafru.it/discord. You can look me up there. And yeah, I'm going to try to figure this out. Maybe there's alternate pinouts that I accidentally used. Anyway, I will keep looking at this. I think next week I should be around as long as kids are healthy. And I think that's it. Thank you to DCD in advance for timecodes, and thanks to Foamy Guy, who usually does their own deep dives, including Tuesday mornings and filling in for me when I'm out. And yeah, I'll see y'all next week. Bye. Here's the window. It's a beautiful day here.